Today we are going to solve the question of Pascal's triangle. As you can see from the animation, we have to fill all of these values. So what can we say about this? We have levels for each row, okay? So this is the level 1, level 2, level 3, and it goes like this. So for each row, we have cells, and this is cell 1 and cell 2. So let's say levels are n and cells are k, okay? So this is n equals 1 and k equals 1, and for this n equals 2, k equals 1, and k equals 2, and it goes like this. So we have a function for that. Let's say we have n levels and we have k values. We have to do this to solve the value. Okay, let's go down there. So as you can see from here, we have to give this outputs in this format. Okay, so let's start. So let's say we are given n as 4. So you remember the outputs. If we are given as n equals 4, we have to find n equals 3, 2, and 1 also. So we need an array that can cover all of that. So we need a big size to fill all of those things. So for example, we are creating an array, and in here I call it values. So we are making an array, but we have to give a size for this array. So how can we do this? So right now we are trying to find the maximum size of our array. So for an example, n is given as 1. So we need to have n values because n equals to 1 and we have just one value. So if n equals 2, we have to have a size of 3. This 2 and this 1. So we can say n minus 1 plus n value. So for here, we are gonna have 3 values at the third step, but we also have to cover these values also in our array. So we have to have n minus 2 plus n minus 1 plus n values. So if you can see from here, this is our function to find the maximum size of our array. And public static, and it's gonna be an integer. It's gonna return an integer, and the name is find size, and it's gonna input a value of level. And in here we have to start a variable from 0. So we are gonna add each time to this variable. I'm gonna name it size. So we are gonna make a for loop, and it should be start from level minus 1. It should be until 0, and each time it's gonna decrease. So in here we are gonna add to the size level minus I. So, and then we are gonna return it. So we have our function, and how can we use it? We're gonna write it in here. Find size level. So this is how we get our maximum size of our array. So if you remember our formula, so you can see that we have a factorial in here, but we have to create a function that calculates the factorial of the number. So let's do that. If you don't know or remember what factorial is, we can write it like this. It means this is the factorial of 5. It means we multiply 5 by 4, multiply 3, multiply 2, and multiply 1. So what it means, we have to start from 1 and increase this number until 5. So if we give 5, we have to start our for loop from 1, and it's gonna go until 5, and each time it's gonna multiply itself by the current number of for loop. So let's create our factorial function. It's gonna be a public static integer. It's gonna return an integer. So I'm gonna name it fact, and it's gonna input a number. So we are gonna say like factorial 5, for an example. Num is gonna be 5, for example. So we have to start our factorial from 1, and in our for loop, our for loop is gonna start from 1, and it's gonna multiply itself until the end. It's gonna go until the number that we give. So in here, it's gonna multiply itself with the current number of for loop each time. So at the end, we are gonna return our current value. Before we continue, I wanna fix a mistake. We should do this like level -1. I did it before like level minus, but it's not gonna work in here. This is our method. So let's say we have a level of 1. We are gonna start our n value from 0. So it's level -1, right? K is gonna start from 0 too. And for an example, at the second step, n is gonna be 1. It's the second step, but n is 1. Then k is starting from 0, then 1. So in that logic, we are gonna make our n value and k value -1 from the normal values. Then our formula is gonna be something like this: n factorial divided by this thing, n minus k factorial multiplied by k factorial. So I'm gonna create a counter, and it's gonna start from 0. So it's gonna track the index of the array. So I'm gonna increase the counter 1 by 1 each time. So I'm gonna have an incremental index. So I'm creating the first for loop. It's gonna be n, and it's gonna start from 0. Then n is gonna be lower than level. Then we are gonna increase each time 1 by 1. Then we're gonna have a second for loop, and it's gonna be k, and k is gonna be actually lower and equal to n, and k is gonna increase 1 by 1. And right now we're gonna create our formula in the coding. So as I say, counter is to track the count of the indexes, and we're gonna take the factorial of n. Then we are gonna divide it to the factorial of n minus k, and we're gonna multiply it with the factorial of k. So this is basically the formula that we are gonna use, and we're gonna increase the counter each time. Then we are gonna return this value in here. So we're gonna return values as a result. I think something's wrong with this code. See, normally if a negative factorial is given, it should be a negative solution. But our function is giving just 1. Let's fix this. We are going to our factorial function, and we are saying that if number is lower than 0, then do this. At first, just take this whole thing, but number equal to number multiplied by -1. But else do the whole thing again, the same thing. Then actually in here we have to multiply the result with -1 also. So we made another mistake. You know the integer data type? It can store this value at maximum, but for an example, if we test our system with more than 16 factorial, it's gonna turn to the negative. And if we try to do this as negative, it's gonna turn to positive. So our values are gonna be very messed up. We can fix this. So let's try by turning integers to the big integers. Also, you have to change this one. So right now we made f a big integer, so we have to change this part to the dot multiply by I. Then in here we have to dot multiply, and for here we have to dot multiply, then let's turn back and change this formula to the big integer method. Dot divide factorial of n minus k dot multiply factorial of k. Then we have to convert it to the integer to equalize to the values array. Also, we forgot something again, so it should be big integer dot value of 1, and we are gonna get this part and add this in here, value of I, and again in here too, because those are integer values. And this part, value of -1. So let's test it. It seems like we found the solution. I'm making the bigger test, and yes, we found the solution. We used 6 as a number, 1, 2, 4, and a random number, and we solved the question.